There's a box of these in almost every home in America. Dozens of identical wax sticks in colors with names like burnt sienna and macaroni and cheese. You've probably peeled the paper off 100 of them without ever wondering what's actually inside. So what turns a lump of petroleum wax into a perfectly shaped, perfectly colored crayon over and over 12 million times a day? Let's go inside the factory. Strip away the color and the smell, and a crayon is almost embarrassingly simple. Paraffin wax and powdered pigment. That's it. The two ingredients Crayola itself lists as the entire formula. Paraffin wax is a byproduct of refining crude oil. When petroleum is distilled, paraffin is one of the leftover fractions. Long chains of hydrocarbon molecules, 20 to 40 carbon atoms each, that happen to be solid at room temperature, but melt at a surprisingly low 99 degrees Fahrenheit. It arrives at the factory not as a block, but as a liquid, delivered by tanker truck and kept heated the entire way so it never has a chance to solidify. The color comes from powdered pigments bought from outside suppliers in pre-measured bags. At Crayola's plant, each bag weighs exactly 3.85 pounds. Some formulas, industry patents suggest, may also include a touch of stearic acid to help bind pigment to wax and add hardness, though Crayola keeps its exact recipe a trade secret. 2 ingredients, endless colors. But it took decades to get here. The company that would become Crayola didn't start out making toys for children, it started out making industrial pigment. In 1885, cousins Edwin Binney and C. Smith took over a pigment business founded by Binney's father. They built it selling carbon black, used to strengthen and darken automobile tires, and red iron oxide paint, the classic color of American barns. In 1902, using that same carbon black, they made a wax marking crayon for stamping crates and barrels. But it was so loaded with pigment that it was too toxic to put in a child's hand. Then, in 1904, Binney and Smith won a gold medal at the St. Louis World's Fair for an unrelated invention, the first dustless white chalk. That success got their salesmen into American classrooms, and teachers, impressed by the chalk, started asking for something else, a safe, affordable colored wax crayon that children could actually use. Edwin's wife, Alice Stead Binney, a former schoolteacher, coined a name for it, fusing the French word for chalk, cray, with oleaginous, meaning oily, Crayola. The first box of 8 went on sale in 1903. The safety problem was solved. Now they just had to make millions of them. Walk onto the production floor today, and the process starts exactly where the ingredients do. Liquid paraffin wax, still hot from the tanker, gets piped into massive heated blend kettles. Workers slit open those measured bags of pigment powder and add them straight into the molten wax, stirring until the color is completely even. No streaks, no swirls. From there, the colored wax is pumped into a rotary mold machine, a rotating steel drum studded with hundreds of crayon-shaped holes. As the mold turns, chilled water circulates through channels inside its walls, pulling heat out of the wax and locking it into its familiar cylindrical shape. Depending on the pigment, some colors hold heat a little differently than others. That cooling takes somewhere between 4 and 7 minutes. Once solid, hydraulic pressure pops the finished crayons out of the mold in one motion. Older factories once did this by hand crank. From there, each bare crayon travels to a labeling machine that wraps it twice for strength in its paper wrapper, glued down with a paste made of nothing more than cornstarch and water. That's not a cost-cutting choice. It's a safety one, because young kids sometimes peel the label off and chew on it. Remarkably, the basic mechanical design of that labeling machine has barely changed since 1943. Molten wax to finished, wrapped crayon. The whole trip takes only a few minutes. Why paraffin though, and not some other wax? It comes down to that long hydrocarbon chain. Those 20 to 40 carbon molecules give paraffin a melting point that's low enough to liquefy easily for mixing and molding, but sharply defined enough that at room temperature it snaps back to a rigid, stable solid, hard enough to hold a point, soft enough to shed a thin layer of colored wax every time it drags across paper. That transfer is really the entire trick of a crayon. friction and pressure shave off microscopic flakes of pigmented wax, which stick to the paper's fibers. Too soft a wax, and the crayon would smear and crumble. Too hard, and it wouldn't deposit color at all. Paraffin sits in exactly the right window, which is also why, over a century after Binney and Smith started experimenting, nobody has found a reason to replace it. What's hard to picture is the sheer volume moving through this process. Crayola's plant near Easton, Pennsylvania burns through almost 450,000 pounds of wax every 5 days. That's roughly the weight of 30 adult elephants, melted down every working week. During the back-to-school rush, the factory can turn out as many as 13 million crayons in a single day. Averaged across the whole year, Crayola says it manufactures nearly 3 billion crayons, about 12 million a day. Lined up end to end, that annual output would circle the entire globe 6 times over. And this isn't a new factory-chasing scale for its own sake. Binney and Smith had been making crayons in Easton since the company's earliest days and built the current headquarters and expanded plant a few miles away in Forks Township in 1976. With that kind of volume, mistakes are inevitable unless they're caught immediately. After molding, every batch of crayons is automatically inspected for breaks, chips, and something more subtle: tiny internal air bubbles, which show up if the wax and pigment weren't blended evenly in the kettle. Any crayon that fails is sent back, remelted and recast, not thrown away. Color gets its own separate check. Workers scan crayons on the line with handheld spectrophotometers, instruments that measure a crayon's exact color value on a standardized color scale and compare it against a strict tolerance. A crayon that's a shade too warm or too cool gets pulled and remelted too. Even something as basic as how easily a crayon snaps in your hand used to be tested by brute force. For years, the only way to know if a formula change made crayons stronger was to physically break tens of thousands of them by hand. It's only recently that Crayola's engineers developed a reliable statistical method to measure breaking strength without that. Every one of the 12 million crayons rolling off the line today has passed through checks that a generation ago didn't fully exist. So the next time you pick up a crayon, notice what you're actually holding. A refined byproduct of crude oil, colored by pigment chemistry, shaped by a process invented to solve a safety problem no one talks about anymore. That the first wax crayons for marking crates were too toxic for a child to hold. Everything about the modern crayon, the cornstarch glue, the specific melting point, the color testing, exists because a company that started out coloring tires in barns decided a classroom needed something gentler. That's the quiet engineering behind the most ordinary object in a kid's desk. Crude oil refined into paraffin wax, pigment blended in by hand, melted, molded, cooled in minutes, wrapped in cornstarch paste, tested for bubbles, color, and strength. 3 billion times a year. All to make sure a 2-ingredient stick of colored wax works exactly the same every single time you pick one up.